Good morning, one and all. For the subject Automata Languages and Computation, today's topic being discussed is DFA and NFA. DFA stands for Deterministic Finite Automata. NFA stands for Non-Deterministic Finite Automata. As you can see, finite automata is what? It's a mathematical model of a machine, of a computer. It has discrete inputs and outputs. Basically, it's a computational model, theoretical computational model with a finite amount of memory. And finite automata accepts type 3 regular languages. The formal definition of a finite automata is given by a 5 tuple value. M is equal to the tuple values are Q, sigma, delta, Q0 and F. Q stands for set of states. Sigma is input alphabet. Delta is transition function. Q0 is initial state. F is set of accepting states. If you look at this transition diagram and want to compare that with the 5 tuple here, Q is set of states which consist of Q0, Q1, Q2, Q3, Q4, Q5. Then sigma is input alphabet consists of A, comma B. Then delta is transition function. Say we are at initial state Q0, the input is A, the next state is Q1, like that. So this delta transition function applied on Q0 comma A will be resulting in Q1. Then Q0 is the initial state indicated by this arrow mark, and F is the set of accepting states indicated by these double circles. Now the finite automata will be given an input string, say A0 to AN, and it is kept on an input tape, and there is a reading head. So, and this will be helping in the transition, delta transition function. Now, finite automata are divided into two types: deterministic finite automata and non-deterministic finite automata. For deterministic finite automata, the machine can exist only in one state at any given time. The machine cannot be in more than one state at any given time. There will be a unique transition in any state on an input symbol. The non-deterministic finite automata, here the machine can existing in multiple states at the same time. So it may go to several states at once. There can be more than one transition for the same input symbol. So here we'll try to highlight the differences between NFA and DFA. So let us say this is my DFA, okay? And what is Q? This Q is a state and alpha is the input alphabet, okay? So there is only one transition for this Q and alpha. And in NFA, what happens is there is no transition, or there is one or more transitions. This possibility is there. So all deterministic automata are non-deterministic. Is it possible to convert a deterministic finite automata, that is a non-deterministic finite automata, into a deterministic? Yes. NFA can be converted into a DFA. Now, how do I differentiate between NFA and DFA? So look at the transition. There will be exactly one transition for every input symbol from each state. There are no epsilon transitions in DFA. In NFA, there can be multiple transitions for same symbol. In NFA, there can be epsilon transitions. Both NFA and DFA recognize regular languages. Now, how do I immediately recognize from a diagram whether it is a DFA or NFA? DFA, look at the outgoing arrow. There will be one arrow for each input symbol from every state. So there are no epsilon labeled arrows. So that is for DFA. If it is NFA, how do I identify quickly? There will be two or more arrows with the same symbol from one state or epsilon arrows or missing transitions. So say here we have exactly one transition, right, for every input symbol, and there are no epsilon transitions. So this is the example of a DFA. So here we have, for the same input symbol, we have two transitions. This is an example of NFA. Here we have epsilon transitions, so it's an example of NFA. Same thing here. One exact outgoing arrow for every state, DFA. Two arrows for same input symbol, NFA. Epsilon transitions, NFA. Transition missing, NFA. DFA has one choice, NFA has many choices. So you can see here, alphabet A is there, it has two choices. First choice is accepted, the second choice is rejected. Here AA, first choice is accepted, second choice is rejected. Here A, rejected. Here A, rejected. A is rejected. So automata hangs on, rejected. Input cannot be consumed, rejected. No transition, rejected. So all possible combinations are led to rejection. So with this, I'll stop here today. Thank you.